Okay, hello. Uh, you should be able to hear me and you should see the desktop. Does that both seem okay now? Can you hear me? Oh, okay. I got the chat window up now. Okay. 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 I hope you had a nice vacation. Okay. And now we have one class and another weekend to go. Okay. So today, actually, what we're going to do is pick up do one more talk about these full event handlers. Now, the homework assignment is finally up. So actually, let's start by looking at the homework assignment. Okay, so let me just show you what it does. So download the homework assignment, extract it. Okay, you have to write an event-driven program. Okay, the program's sketched out for you here. Okay, this program, what it does right now is it shows the initial screen of the program, and it's got empty event handlers. Okay, so they're all set up for you. The event handlers have all been set up. So well, actually, they haven't been completely set up. They're just outlined. The event handlers are here. You have to connect them to your program. This just generates a scene and displays it. So here's a demo program. If you run the demo program, okay, the demo program is this jar file. You may or may not be able to double click on the jar file. It depends on which version of Java your Windows system is connected to. For example, on this machine here, if I double click on this jar file, it tries to run onto JDK 8, but this was compiled with JDK 11, so it won't work. I get a weird error message. That's because the jar file was compiled with JDK 11, but my Windows is still trying to use JDK 8. So I put a separate command script in there that runs the jar file on your current, whatever's in your path. Now on my computer, what's in my path is JDK 11. So the Explorer is trying to use JDK 8, but what's in my path is JDK 11. So if I double click on that one, it runs. Okay. Now, depending on your computer, you might be able to just double click on the jar file. Like if you don't have multiple JDKs on your computer like I do, you can probably just click on the jar. You can probably just double click on the jar file. This is not an executable jar file. That's just a library. In fact, this jar file makes use of that library. But this is an executable jar file. So if you double click on it, it should run. But because my machine has so many JDKs on it, it's a little bit goofy. Okay, if I had compiled this with Java 8, then that jar file would work, but it won't. But you can't run a Java 11 program on a Java 8 JDK. All right, now the program I just showed you, this code here draws this initial screen here. Okay, in fact, if I compile this program, you'll see what I mean. This compiles and runs. Okay, it builds that initial screen. But this doesn't do anything. If you click, you can click all you want, it won't do anything. The program, what you're supposed to do is you're supposed to be able to drag and, when you click on a box or a shape, you can drag that shape. Okay, so when you click inside of a shape, see, when you click inside of a shape, you can drag it. And if you have overlapping shapes and you click inside both of them, you drag both of them. Okay, and when you get to the end of the window, if the mouse goes off the edge, you stop dragging. Okay, same, if you go off any window, oops, if you go off any window, you stop dragging. If you go off any edge, you stop dragging. Okay, and so your program has to respond to keyboard events and update the scene accordingly. Now, another thing your program has to handle is, so that's keyboard events. Your program has to handle keyboard events. Your program also has to handle the event of changing the shape of the window. Okay, so if you change the shape of the window, the program still works. Okay, notice that when you change the shape of the window, the circle becomes an ellipse. Okay, and another thing you have to be able to handle is, well, keyboard events. Okay, so if I type, see, there's a little bit of message over there that tells you what keyboard actions you can use. So for example, if I type the H key, I get that message over again. Okay, and if I type the I key, see, I for mouse debugging information. Now it starts telling me things like where I click the mouse, which object I'm dragging. Like now I'm dragging the diamond. So how much, another thing it says is, like, if I just drag the mouse across the screen, it told me how much the mouse shifted by. Okay, so it's showing me the mouse deltas. Like if I go across the screen like this horizontally, notice I have delta y's are all 0, but I have lots of big delta x's because I was moving in the x direction. If I go down this way, now I have delta x's are all 0, but the delta y's are changing. And they were decreased, the delta y's were decreasing. The delta y's were, I was going down. Going down is moving in the negative direction, okay? Actually, yeah, well, actually, I think I have that maybe mixed up. One of the troubles with the y-axis is sometimes you measure it going up and sometimes you measure it going down. The x-axis is always measured to the right, but the y-axis, it varies. No one agrees from one part of a GUI system to another where y measured up or y measured down. Here, in this, the 0 is over here. See, there's 5, 5. See, if I go way up in this corner, there's 0, 0. Now I'm at 2, 2. Now I'm at 2, 1. And down here is the most positive. So if I'm going down, I'm actually increasing y. So I probably have the direction of that swapped. Yeah, I was thinking of calculus. When you move down, you're decreasing y. But technically, in this GUI window, moving down is increasing the y coordinates. I probably should have had that the other way around, that y is increasing, because 0 is up here for y. This edge is 0 for y, and this edge down here is the maximum. Okay. All right, and now another thing you have to respond to besides the I command. Now the I command, see, the I command turns off and on the information. You'll need that information for your when you write your program. That information is real useful to you as you debug your program, but you can turn it off and on. Then you can also turn off and on the debugging information from the renderer. So if I hit the D key, this is debugging information from the render. So every time I generate an event, I get debugging information from the render. That probably won't be really useful for you in this homework assignment. So you don't really need to know, these models are given to you. You probably don't need to debug them, but you can turn on or off the render's debugging information. So now the render's debugging information is turned off. Then the other thing you can do is turn the clipping off and on. Like right now, clipping is off. There's clipping is on by default. Clipping is on, but there's turning it off. So now you get these kind of weird things. But if you turn off clipping, you gotta be careful if you go off the top. So you remember that kind of crashes the render. Okay, so you can turn off and on clipping, and the other thing that's interesting is you have to write a R key. Okay, notice that the window's not square, so the sphere is not round and the squares are not square. So the R key is supposed to reset the window to being a square. Okay, so if I tap the R key, see, the windows become square again. Okay, and if I tap the Shift R key, the window becomes square again in the larger way. Okay, now think about it. If the window looks like this, there's two ways to make it square. I could make this dimension longer to match that one, or I can make this dimension shorter to match that one. Okay, so I have two ways of turning this rectangle to a square. Shrink it horizontally to make it match this shorter dimension, or grow it vertically to make it match this longer dimension. And that's the two keys. The lower R shrinks it, and the bigger R grows it. So the lower R shrinks it to the smaller of the two dimensions, and the capital R grows it to the larger of the two. So here, R, see, shrunk it. But if I go like this and do Shift R, it grows it. It turns it square. Okay, so that gives you just things to events to handle. You know, that command is there just to give you something else to handle, something to do. Okay, now in the code, you have to fill in a bunch of these, not all of them, but many of these event handlers. And you have to tie them to the scene. See, here's the scene. Here's all the code that created the scene. But these event handlers, many of them are supposed to update that information. So like the mouse events are supposed to update these models. Okay, there's the models. They're supposed to be moved around. You know, the mouse should make them move around. Here's where I put them in their initial place. Okay, I put them in the right place for you. Now you have to take over with these event handlers and let the user move them around by, you know, by clicking and dragging. Okay. Now the homework's got a long explanation because I try to give you I tried to write pretty detailed step-by-step information about how to go about writing this. So it goes kind of, you know, it's kind of long. You know, if I just gave you this and said, write this, that would be way too hard. Yeah, you know, at this point, you know, most of you probably never written a event handling program. So just to say, write this would be way too much. Okay, so I try to give you step-by-step instructions about how to build the program, you know, carefully. And a big part of building the program carefully is this turning on debugging information over there, the I, using the I command to see where you're clicking. Okay, that's a big part of what you need to do. Like a lot of the information in the description is to tell you how to write the information that gets shown over here, because it's that information that helps you understand what's going on. Okay, so the homework assignment tries to explain very carefully and step by step what order you should do things in. Okay, and as I point out in here, when you do things step by step, I recommend that you save your steps. Don't try to write this whole program. You know, you cannot write this whole program in one file. You have to write it step by step. But I think as you write it step by step, it's a real good idea to save your steps. When you finish a step, usually most steps are one paragraph. When you save a step, save that, because when you go into the next step, you could easily goof things up and end up with something that's worse than you started with. The best defense for that is either use a version control system or save your work as you got a good, when you got a good chunk working, save it as a file, give it a nice name, so that you, if you modify it to do the next step and things get really messed up, you have something to go back to. You know, or you can figure out, you can use a difference between what you've messed up and what was working before to see what maybe you accidentally did wrong. I mean, I do my coding that way all the time. You know, keeping working copies of something as you modify them is really useful, because it's real common to just goof up, make some kind of dumb mistake, something that was working no longer works, and you can't figure out what you did wrong. But if you can just compare it with a working version, yeah, it makes it a lot easier to figure out where you made some change. Sometimes it's something as dumb as you accidentally changed a J to an I. You know, you just changed some letters somewhere, accidentally changed a variable somewhere, and broke something. But that's where file differencing programs can come in. They could show you where you made a change that maybe you forgot about. Okay, so as you go through all these steps, I recommend you keep copies of each working step so that you have something to ask questions. You know, you can use it as a reference for asking questions. You can use it for fixing mistakes that just pop up out of nowhere. And also, they'll help you if you come back to this a year later and want to understand what you wrote. If like a year later somebody asks you to write GUI programming, this would be a good example to go back to. And if you've got a detailed outline of how you wrote it, it can make it a lot easier to go back and understand what you did. Okay, all right. So, and you've got the demo program to give it to answer questions with. If you want to know, should it work a certain way or work another way, a lot of times you can find that out by trying it in the demo program. Okay, and it's kind of fun. It's actually kind of a neat thing. It is kind of a nice. It's kind of quirky to work with. You can create nice little. You can create shapes and move them around.
Inscribed and circumscribed circle.
Yeah, yeah, and then you can, you can try to get them really lined up right. See, like, I think that one's lined up right now.
Yep.
Yeah, now you can move them all around. If you click over here, you'll move just those. Okay, yeah. So, because I was inside only 3 of the shapes. Okay, so that's kind of fun. Yeah. Try to turn it into a game. I can't imagine what kind of game you could turn this into.
Well, that looks like a nice mandala, just the way.
Yeah, yeah. I mean, I chose the shapes because they fit together nicely. Yeah. So a circle, a diamond, and 3 squares. Oops. Yeah. And if you look, one's called circle, one's called square 3 is the big square, square 2 is the middle square, square 1 is the small square, and then there's the diamond. Okay. And notice that the circle, you have to click inside of it. See, if you click near it, it doesn't work. You have to click inside of it. Same with all the squares, same with the diamond. You have to click inside of it. See, if you click outside of it, it doesn't work. You have to click inside of it. Okay. Right. So you have to click inside each of these items. Okay. Let me think. Anybody got a question? Anybody think of a question real quick about this? Anybody got a question?
It might not necessarily be about this, but is there some way that using like this GUI, you could like maybe say right click on one of them and have it create a copy of the same shape?
Sure. Oh yeah. I mean, yeah, you could play around. You could do a lot with this thing.
Okay.
Yeah, you could have right click, create another circle. Sure. You'd have to learn how to you'd have to learn how to handle the right click mouse button. Now notice that I'm right clicking my mouse button and it's being treated just like a left click because I didn't teach the code to distinguish a right click from a left click.
Right.
So right now the right clicks and the left click, but if you wrote the code a little more carefully, you can distinguish between a right click and a left click, and you can have the left click, the right click do different things. Yeah.
Okay. Cool.
You could have the right click let you I don't know, like change the size of it. Yeah. Maybe if you right clicked on a corner here, you could grow that square instead of dragging that square by left clicking, you could right click the corner and grow the square. Now, if I right click this corner, it does. Yeah, if I right click, it drags. Yeah, so it doesn't matter if I left click or right click, it drags either way. But I could have the right click do something different. It's just learning more about the event system. So there's actually quite a bit you could do with this example. If you continue to play around with it, you could conceivably add quite a few features to it. Yeah. And you could add more keyboard commands. Yeah. You could add more keyboard commands. You could make the right mouse button do things, and you can also do things with like control clicking, like the I command does something by itself. Okay. Or like the H command does something by itself. But I could have it so that if you hold down the H key and click, that's a key click command. You can make that special. You can make key clicks command do things. You can combine a mouse click with a keyboard command. Okay, so you can actually create all kinds of different things if you want. Okay, so I thought these were enough interesting things in here. Okay, to give you a variety. You've got Windows shape events to handle. lots of mouse events to handle, and a few keyboard events to handle. Okay, so you got a couple keyboard, those are the easiest. The window shape isn't very much to do. The hard one is the mouse clicks. Yeah, there's a lot of work to do to get these mouse clicks to work. That's quite a bit of code, quite a bit of work to get these things to work. Okay, all right. Okay, so read the description carefully. Yeah, it's about 4 pages. It's all together. It's I think 4 pages long. If you print it out, I think it's 4 pages long. Okay, and read it carefully, and then just start from the beginning. You know, start with the very first step is to just have some of these event handlers just print a message over here. But you know, just print a message. Don't interact with the GUI. Don't interact with this. Just when somebody presses the mouse button, you get a little message over here. Just get the mouse button to work so that when the mouse button is clicked over here, you see something over here happen. Okay, that's the first step. Yeah, so that's the that's just this one sentence. Yeah, that's your first step. Give the program very basic event handlers that just print the event objects to standard out. There's lots of examples in the folders from class that just do something like that. Okay. All right. So now let's go and look at the code, the demonstration code that that you're going to need for getting ideas from. Okay. So most of the ideas you need are either in this folder or this folder. A lot of what you need is in those folders. Okay. So let me unzip them. Now, actually, there's probably better examples in this folder than in the renderer folder. The renderer folder, in the renderer folder, this program is the one that would be most helpful for you. Okay. It doesn't do any mouse events, but it does, it's a pretty good example of a GUI program. Okay. It does keyboard events. This one, the keyboard lets you move things around. So instead of being dragged around by a mouse, things are moved around by keyboard commands. But it's a good example of a GUI program that interacts with what's on the screen. Yeah. So it's a GUI program. It's keyboard events moving an object. Now you need a mouse event to move an object, but this is a good start. You know, make sure you understand how a keyboard event can move a geometric object that's being drawn by the renderer. Okay, right. So this example is a real good one, the interactive cube, and the other ones are very similar. That these programs all have almost the exact same structure to them. Okay, yeah, just that they do a lot more models. Yeah, so yeah, this one, instead of it moving around a square, it lets you look at any kind of model. See, it displays one instance of every possible model, but then you can just move it around with the keyboard. Okay, so it's just moving the mod. It's just an elaborate version of the first one. The first one just gave you a cube, and you can move the cube around. Now you can see what every kind of shape model that's in the library. The library has all these different shapes, and you can just look at all the shapes. Okay. Oops, the clipping is not turned on. Okay, so you can just see all the different shapes, but they all do the same thing. They just move up and down using keyboard commands. There's no mouse commands in these examples. There's no mouse commands. Okay, But so the simplest one is Interactive Cube. Okay, that's a good model for you to look at, that program there. Okay, now in this other folder, there's a lot more examples. And today I wrote some new stuff. I thought of a good way to explain what's in all these folders, because I realized that there was a lot of examples and a lot of folders, and it dawned on me this morning what's really going on in this. The ones that are important is this folder, and this folder. Okay, so I wrote a README. This is new. I wrote that just this morning. Okay, what's really going on is that I realize that there's two orthogonal concepts. Okay, two ideas are being distributed here, and they're along two different dimensions. Okay, so what are the two orthogonal dimensions? Okay, one dimension is what are all the different events that can be handled? Okay, so one thing you want to say is how many different kinds of events does Java let me deal with? Okay, that's this folder, watch events. And it lets you watch action events, adjustment events, component events, focus events, item events, key event, mouse wheel, mouse window, mouse motion. Okay, so it's letting you see all the different kinds of events. Okay, that's one dimension to think about. Okay, now the other dimension, see, watch events is that one dimension. The other dimension is different coding styles for the event handlers. And this is the more difficult dimension. Okay, there's a bunch of different ways that people write event handlers. You can write them as classes, you can write them as nested classes, you can write them as inner classes, and you can write them as you can just implement them directly. There's essentially like 5 different styles of coding. Now, I adopted one style, and that's what your homework is. So in fact, this dimension, I finally decided isn't really, this dimension is important if you really want to be a GUI programmer. And if you're going to, it's also important if you're going to look at other people's code, because there's no one way of doing this direction. The coding styles are all over the place. There's about 5 of them, and the world uniformly uses all 5 of them. No one of them is preferred. So you see people using anonymous inner classes, nested inner classes, separate objects. You know, they're just all over the place. For the most part, for your homework assignment and all the examples I put in the renderer, I used one style. And I finally decided that was the style I thought that I liked the best. Over the years, I keep switching, because if you look at the code that's out there in the real world, you see no one seems to really agree on which one of these event handling styles is better. So I kept trying all these different, actually here, there's 5 different styles right there. I wrote these. Oops. If you open these folders, they look like they're the exact same thing. But they're all written in, this code is written in a different style of this code. Okay, you can kind of, like this code here, and then this one here. Notice how this is just a class, but this is a class that implements event listeners. In this style, the program is the event listener. In this other style, the program is not the event listener. You go down here and you find that the event listener is a separate class, but it's an inner class. That's another style. The event listener is an inner class. So here's the thing that implements the event handling interfaces. So this is the guy that implements the key listener. Down here is the guy who extends the key adapter. That's a trick. Okay, so that's implementing the key listener, but it's a different aspect, different style. It's implementing the key listener by extending a key adapter. Okay, and then if you look at this other folder, The event listener is a third style. It's an anonymous inner class. This is something called an anonymous inner class. So there's the key listener, but the key listener written as an anonymous inner class. Okay, so the code, these folders look like they're the same thing. If you open them, you just see the exact same files, but each one's written in a different style. Okay, so this demonstrates 5 different styles. Style 1 is the one that I pretty much decided I think is the better one. Actually, no, it's style 5. I'm sorry. Style 5 is the one we're going to eventually use the most. Okay. And style 5 is a version of style 1. Style 5 is a version of style 1. Okay. So this is the harder dimension to go along. The different styles is a harder dimension. Okay. So for the homework assignment, you don't have to worry about that. For the homework assignment, you're just going to use one dimension. The first dimension is all the different kinds of events. Okay, and you have to handle keyboard events, mouse events, and window events. So you have to handle 3 of the different kinds of events. The other dimension is how to handle the handlers folder. Okay, if you look in the how to handle the handlers folder, that tells you the different styles of how to write event handlers. So this steps through, actually, there's not 15 styles, but there is, I do slight variations on some of the styles. There's really about 5 different styles, but I do slight variations on them. Okay, so but every one of these is something you'll find out there in the real world. And every one of these is there in everybody's library. If you're doing Windows GUI programming or HTML GUI programming or Python GUI programming, you'll see these different styles. Not every language allows you to do every one of these styles, but every language has at least a few of these styles built into it. Okay, so like Python GUI programming may not have all of these different styles in it. Like HTML, I don't think it does. I don't think HTML GUI programming has all these different ways of doing it, but I don't really know for sure. Windows programming does, has all these different ways. And that's one of the reasons why GUI programming is hard, because you pick up 2 books and they look like they're talking about almost different subjects, because one book picked one style and used it all the way through. Another book picked a different style, used it all the way through, and their examples don't even look alike, even though they're both showing you how to write GUI programming. Okay? Here I tried to show you all the different styles. Okay, all right. So this folder is the different styles of event handlers. This folder is the different kind of events. For your homework assignment, this one's more important. You want to know how to handle different kinds of events. Oh, for the homework assignment, you're using that style. See this interactive frame version 3? That's the style actually that the homework assignment's written in. So as I point out in the explanation of the homework assignment, you might want to look at this one file. This one file is a little bit of a clue as to how to write your homework assignment. Now, it doesn't handle, it handles key events. Okay, so it handles key events. Okay, and it uses the style of event handler that we use in the homework assignment. Okay, so if you're curious, you can look at all these other styles, but that's the one the homework assignment uses. This version 3 one. Okay, all right, so okay, now there's another folder in here that's orthogonal to these 2 orthogonal things. Okay, so this is all the different kinds of events. This is all the different kinds of ways of styling the handler code. This is this isn't a dimension, this is just an idea, but an important idea. This folder is showing you that events happen on a thread. The whole point of this folder is to show that events happen on a thread. Okay, that's a more advanced idea, but it's an important idea. So it doesn't affect your homework assignment. Yeah, I think it's something that's worth knowing about, but it doesn't affect the homework assignment. Your homework assignment this 2 lines of code here handle the thread issue. Those two little lines of code are, and that folder explains what those two lines of code mean. Okay, so those two lines of code start the program on the event thread. Okay, but we don't really need, you don't need to worry about that. So I gave you that piece of code. I gave you those two lines. Those two lines take you, it's amazing how much is in these two lines of code. You're launching a Lambda expression. See, you're launching a Lambda expression on a separate thread, okay? And the Lambda expression is calling a constructor. So like almost all of Java programming is in these two lines of code. Lambda expressions, constructors, objects, threads. Yeah, yeah, yeah. The amount of knowledge you have to understand. And you guys should, yeah, you may don't know what these two lines of code do, but you're ready to learn what these two lines of code do. But in this class, it would take us too far afield to actually really spend the time to explain what those two lines of code do. But if you read that folder, if you go through that folder, event dispatch thread demos, and read some of the examples in the folder, it explains it, you know, it'll show you, I mean, it takes this much work to explain those two lines of code. Yeah. Programming is weird. You know, there's a notion of lines of code. You know, how many lines of code should a programmer write every day? And people argue about this stuff. And it's usually kind of silly because I can write 5 lines of code that can take me a whole day to write, and you can write 100 lines of code in your sleep if we're writing different kinds of code. You could easily write 100 lines of boilerplate code in your sleep and not think about it. Then you could write 2 lines of code that take you maybe an hour to figure out, or hours to figure out. Like in the algorithms class, you may have seen that kind of stuff when you write balanced AVL trees and all kinds of weird things. You know, it's, you know, counting lines of code is a bit silly because not all lines of code are created equal. Some lines of code do a whole lot more than other lines of code. That's actually even just, that's really one line of code. See, that's, I just wrote it out as 3 lines of code, but it's really one line of code. You're calling that method with that parameter. You're calling that method with that parameter, but the parameter of that method is a Lambda expression. And what that method does is it launches that Lambda expression on a thread. And that Lambda expression instantiates a constructor. Okay, so there's a huge amount going on in literally what is just one line of code. Okay, but that takes care, from our point of view, of all the issues in this folder. The issues are worth learning about, but not necessarily in this class. You know, we would have to spend too much time explaining a lot of what's in here. Okay, it's interesting to read. The examples are simple. They build up from simple to complicated. So you can kind of go through, and there's actually 2 sequences of program. This one demonstrates the idea of a thread, and then this one shows you how to solve a bug that comes up. If you don't do things right, you get buggy programs. Let me see if I can see if one of them will be buggy for us. Okay, see that program? There's a GUI in there, but the GUI didn't show. If I minimize that window and maximize it, look, see, there's where the GUI was just that label, but notice it wasn't there a minute ago. So let me run it again. There's a bug in this program. See? Now, watch, if I resize the window, see how that popped up? The GUI was not displayed correctly. There's a little bug in this program, and the bug has to do with that the event dispatch thread. This program is written in a way that you see in a lot of books, and it's actually not correct. And the program has the problem that the GUI doesn't get initialized properly. The bug is in initializing the GUI. Okay, so there's so this sequence of examples show you this bug and show how to fix it. Okay, so by the time you get to I think the last one, it'll always pop up correctly. This one will never pop up without the little hello there, but the other ones will, because the other ones have the bug in them. And this sequence of programs show how to get rid of that. And the bug is those 2 lines. This 2 lines of code are the 2 lines of code that solve the bug. If you don't do it quite this way, your program won't initialize itself correctly. Okay, so this aspect of GUI programming we don't need to worry about for the homework assignment, because I wrote it with the proper initialization. This is the proper way to start the GUI, so that's just done for you. Okay, so you have to really worry about these guys. You have to worry about the event handlers. The style of the event handlers is fixed for you. I wrote it in one style. So you just need to implement the event handlers. Okay. Now, let me show you one more idea. Well, remember, the broad outline is we're dealing with 5 things: components, containers, layout managers, events, and listeners. Right now, we're really worried about these guys. Okay, so we're really emphasizing the events and the listeners. Okay, and these are all the different kinds of events, and there's for each kind of event, there's a listener for it. Okay, now the other thing, let me see, we're trying to remember where. Okay, this picture here. This is we've talked about this picture. This picture outlines the idea of the event, how the event, like, okay, there's events and listeners. How do they get fit together? How do you put them together? That's what this picture is. This is a event and this is a listener. And this object is the source of the event. This object is the listener event. And this object is the event itself that comes from the operating system. The operating system generates the event. And actually, the operating system, remember, it's the operating system that owns the mouse. So the operating system knows when a mouse is clicked. So the operating system generates the event and gives it to the Java virtual machine. The Java virtual machine actually bundles the event in a Java object that, the operating system will give it to the Java virtual machine as a C data structure. So the operating system will build a C strut out of the object, give that object to the Java virtual machine. The Java virtual machine will translate it into a Java object. And then the Java virtual machine says, where did it come from? Well, it came from this GUI object. Maybe it's a button, maybe it's a window, maybe it's a slider. So the Java virtual machine goes to that GUI item and says, okay, what do I do with this event? And the Java virtual machine looks for this list of event listeners and looks down that list and says, oh, you want me to call that handler when the event happens. So when this event happens, the Java virtual machine goes to the source of the event and says, what do you want done? And it looks in this list of event listener objects and calls that event listener. Okay. In your homework assignment, that's these guys. Okay, these methods here, well, these methods are the event handler methods, and they're sitting in the homework 3 object. See, the homework 3 object implements all these listeners. So in this picture here, this method is sitting in the homework 3 object. So this is a homework 3 object. The event listener object is a homework 3 object. Okay. And you'll have to instantiate well, here's the constructor for the homework 3 object. Okay. So that constructor has to do something to basically say, I'm the listener. So you have to, look at the example code, but that homework 3 constructor has to basically set this up to say, I am the listening object. Okay, and I hold the event handler methods. Okay, so homework 3, this object holds all these methods. Okay, so homework 3, this is the style part of it. The style here is that the program is its own event listener. Okay. Now here's something that's a little bit tricky. We never say anything about this object over here. When we talked about this picture, we never talked about this thing. Okay. So the last thing to tie all this together is what is this object over here? Okay. So this is the event object that comes from the operating system. It says I'm a mouse event or I'm a key event. If it's a mouse event, it'll say where on the desktop you click. If it's a key event, it'll say which key was pressed. Okay. The event object comes in, the Java virtual machine looks for the source of the event. Was it a button or a keyboard or a slider? And says, okay, now who handles the event? It goes over here and then calls this method. The whole purpose of an event handler is usually to update something in a program. You want the event handler to essentially feed back to the program some information, the information that the user clicked here or clicked there or made a choice or something. So this object represents the state of your program. Your program is in some state. So for example, if I run the homework demo program, there's the state my program's in. My program is in the state that the circle's here, the square's here, that square's there, that square's there, that diamond's there. That's the state of my program. That information's stored in some object, and you're going to have to actually design this object as part of your homework assignment. You have to have something that remembers the state of everything, okay? Now, when I click and move something, I've updated the state of my program. Now my program has that circle set at a center somewhere different. Mostly, what is the state of all these programs? It's the center of each. You need to know where's the center of this guy, the center of this guy, the center of this guy, and the center of this guy. They don't change their dimension. Like if you could grow the circle or shrink the circle, that'd be part of the state of the program. In this program, the state is 5 centers: the center of that guy, center of that guy, center of that guy, center of that guy, center of that guy. The reason you want to know the centers, like when I click there, that click is inside the circle because the distance of that click from the center is less than the radius. Okay, so that's how I know that I clicked inside that circle, because the mouse click was there. I'm keeping track in my state object where the center is. I can compute the distance from the center to my click, and if it's less than the radius, I'm in the circle. In the case of the squares, you just do some inequalities. You know where the center is, so you know where that left edge is and where that right edge is, where that top edge is and where that bottom edge is. So if I click right there, I can check whether I'm below the top edge, above the bottom edge, to the right of the left edge, and to the left of the right edge. If I am, I'm inside. Okay. Same here. When I click, I know where the center is. If I know where the center is, I know where the left edge is, and because I know the size of this square, it doesn't change. So if I know where the center is, I can figure out where the left edge is, the right edge is, the top edge is, and the bottom edge is. Okay, so then if I click, I can tell, am I below the top edge, above the bottom edge? Like now, I'm to the right of the left edge, I'm above the bottom edge, I'm below the top edge, but I'm to the right of the right edge, so I'm not inside the square. Okay, so you're gonna have to have code that uses the state information. When it gets a mouse click, it checks, am I in here? Now if they're overlapping, now that mouse click right there is inside the circle and inside the square. So but the key is that when the mouse drags and moves things around, every time the mouse is dragging something, you're updating this object. There's an object in your program that's going to have to keep track of the state of your program. Okay. Now, here's the tricky issue. This object and this object and this object could possibly be different objects. This object is the object that generated the event. That's a button. This object holds the code to call when that button is clicked. This object holds the state of the program. Somehow, these two objects have to communicate with each other. And this is actually one of the driving forces of object-oriented programming, is this problem right here. If you're interested in like how programming languages came to be what they are, this was really one of the motivating design issues. It's a pain to get these two guys to communicate with each other. Okay, this object holds the code that you call when an event happens. This object holds the information that needs to be updated when this code is run. How do they communicate with each other? One possibility is take all this state information and dump it in there. And that's pretty much what we're doing in our homework assignment, which is kind of the easy way out, okay? It's a little bit of the easy way out. Just blur these two objects together. But that's where all the different styles of event handlers come in. That's part of it, is there's multiple ways, good and bad ways, to have this code talk to that data, okay? So this is code and this is data, okay? Right? So this code has to talk to that data. And like I say, one of the easiest things to do is just dump all that data into that object right there. And that's kind of what we're going to do, okay? In this one here, the state information is more or less all these models, okay? Now notice these models are where is it? No, there's a bunch of data here, okay? And right now, like in here, suppose you're in this method here, key pressed. Can this method access any of this data here? See, that's the feedback problem. Oops. That's the feedback problem. This highlighted stuff up here right now is where my state information is. And my code that has to handle it is down here. Okay, now this is a Java problem. Can this code access this data?
No,
Why not?
they're in different scopes.
Yeah, they're in different scopes. See, all this data is in the scope of that method, the constructor. Now, they could possibly share. How would I do that? You're gonna have to think of it. If I want this method to have some access to this information, what can I do?
Instance variable?
Yes. Yeah. Start moving possibly some of these variables from being local to the constructor to possibly being up here. So for example, maybe this guy, maybe you'd want it up there. Now it's an instance variable, not a local variable. Now as an instance variable, it's visible down here. Okay. Okay, so you have to start thinking, you're gonna have to start thinking about things like that. You have to solve this communication problem. Now notice what I'm kind of doing now is I'm not really dumping this information in here. I'm making, I'm making this information, I actually am dumping this information up here. I'm making these two objects the same object, and I'm making the information instance data to this event handler. Okay, so I am taking this and dumping it into there as instance variables. Okay, so I can take, like, another thing is I could take, I can move one of these models up there. The thing is, you have to figure out what is it you want to, what do you want these methods down here to see of this data up here? Okay. Okay, so you have to solve this communication problem. Okay, now down here I outlined four different ways of solving that communication problem. The one we're using is number one. The object that holds the program state is its own event handler. So essentially bundle these two objects together, which is what homework 3 does. It bundles the object that is the program is actually the object that does the event listeners. So if you start putting things in instance variables, they become visible to the constructor and they become visible to the methods down here. Okay, so you may find yourself needing to move some of these things from down here up to the range of instance variables. okay? But you don't need everything. Not everything that's in the constructor, not everything down here needs to be up here. The less you put up here, the easier your code is to understand. So you want like the minimal amount of stuff up here so that you can solve this problem that when an event gets called, it can update the appropriate information. Now, there are other styles of programming. There's these other styles here. There's lots of ways of writing the communication between these two. Okay, so one object-oriented way to do it is to use instance variables. Another object-oriented way to do it is to use inner classes. Okay, inner classes take these what an inner class does, more or less, is it takes these methods and moves them, kind of looks like this. You take these methods and you move them up here. Okay. Now that doesn't make sense. You can't write methods up there. But notice what makes sense now is that they're in the scope of all this data up here. But you can't just stick them there. So you have to stick them in something called an inner class. So you have to define something called an inner class to wrap these things in. The syntax is kind of weird, but then you wrap these guys in an inner class. Okay. But now they're sitting inside of your constructor, so they have access to all the local variables in the constructor. Okay, it's a very interesting way to solve this communication problem. You kind of take, you're kind of taking this code and putting it inside, instead of taking this data and putting it inside this object, you're taking this code and putting it inside of this data in a weird way. You know, it's kind of like the complementary way. Instead of taking the data and sticking it up here as instance methods, you take the code and you stick it down here as an inner class. You take the code and you stick it up here with this, with the data, but you have to wrap it in what's called an inner class. And the syntax is a little bit weird. Okay, so that's this style too. You use a nested. Some people call it a nested class or call it an inner class. You know, you make the event handler a nested class of the class that holds the data. So you move these guys into there. Well, that's a big part of object-oriented programming. These nested inner classes are like a very famous, sophisticated, advanced form of object-oriented programming. And they were partly invented to solve this problem of event handlers needing to talk to the code, the event handler code needing to see the data it's supposed to update. There's the code, there's the data. You know, you don't necessarily want them bundled together. You maybe for various design reasons, they may need to be separated from each other, but if they're separated from each other, they still have to communicate with each other. Okay. Now, these first two solutions don't really keep them separate. The way we're doing it in homework 3, we're taking this data and cramming it into this object. That's not separating them. It's slapping them together. The inner class thing takes these methods and sticks them inside of here. See, so that's not separating things. Okay, so you're going to take these methods and stick them essentially inside of your scope by sticking them inside of an inner class. So another possibility, like if you really, really, really need to keep this object separate from this object, then that's style 4 over here. But it's the hardest one to do. The event handler object is an instance of a class that is separate from the class that holds the program state. That's actually the trickiest one to do. Okay, and a lot of sophisticated programs, this is why, have you ever heard of Spring and all these frameworks that people use for writing really elaborate code? Guess what it's doing? Spring Framework is a framework for solving this problem, among other things. But one of the big things that Spring Framework does is solve these kinds of problems, especially this kind of problem. You need to keep this guy really separate from this guy. You can't cheat like these other things do. You can't, you know, it's not in a really sophisticated program, it's not good enough to cheat and say, oh, I'll just take all this data and slap it up in here. Or I'll just take all these methods and embed them in here. In a more sophisticated program, this and this need to be kept separate, but then you have to work much harder to get some kind of way of communicating between here and here. Okay, 3 is just another kind of inner class. See, nested class, inner class. There's actually a slight technical difference between nested classes and inner classes. They both do the idea of taking the code from what was down here and sticking it where you want it. Sticking the code inside the data. But there's a notion of an inner class and a notion of a nested class. They're slightly different. Real similar, but slightly different. So you could do it as a nested class or an inner class. Okay. So 3 and 4, 2 and 3 move the code into the data. 1 moves the data into the code. 2 and 3 move the code into the data. And 4 is kind of the really right way to do it. Keep the data and the code separate, but that requires a lot more effort. And if you read books on GUI programming or just Java textbooks, they kind of randomly bounce between these 3. And some of them literally bounce between them. Some will do it always this way, or maybe always this way, or always this way, and they almost never point out that if they bounce between them, they usually don't even mention that they're bouncing between them. If they do it this way, they almost never mention that there's 2 other ways. If you read a book that does it this way, the way you find out that there's this other way is you pick up another book and try to figure out why it doesn't look like the one you just read. You finish reading this article or this book that explains this thing, then you look up another book and it's doing this way and the code doesn't look alike, and they never mention the other way, and then you have to put 2 and 2 together. And then almost nobody talks about this one because it's the hardest one, but it's pretty much what gets used in the real world. It's what you get when you start doing what's called, I put a link in here in the folder. There's some real fancy jargon that goes with this. No, I'm trying to remember where it is. Oh, inversion of control. Okay, there's a Spring framework is built around something called inversion of control. And inversion of control is trying to solve this problem that we're talking about of like getting these guys to communicate with each other in a way that when you're writing tens of thousands of lines of code works. Not when you're writing 2 or 3 files with 100 lines per file, but when you're writing something that's on the order of tens of thousands of lines of code. How do you get this stuff to be, and you've got dozens and dozens of programmers working on the code and there's tens of thousands of lines. How do you organize it? Okay, and how do you solve this problem then? And this is kind of the modern way of doing it, something called inversion of control. Okay, and it's essentially this idea made even harder. But it works for the really big programs that they write. Okay, web applications. When this is spread out as a web application where maybe the event handlers are in the client, but the state information's on the server. See, that's when things that's when I'm saying you have to sometimes keep these things separate. This could be JavaScript code in a client where this is data stored in a database. The state is in a database and the code is in the browser, and they're separated by a few thousand miles. That's the extreme of this, but it's still this problem. An event happens in a browser. You click a button to say, order my can of soup. You click on the button that says place order. The state information's on the database in a server somewhere, but that event has to manipulate that data. That's the extreme example of what we're talking about here. Event on a client, state data on a server somewhere. How do you get this thing to communicate over a network? Okay, so it's this picture, and then you're forced to do this because this is on the client in your browser. This is in the server over at Amazon. Okay, so this is the goal eventually, but it makes things real hard to keep these 2 things separate. The code that handles the event from the data that the event is supposed to manipulate. When you're forced to keep these guys truly separate, there's a lot more work that has to go on. So we're cheating. We're either going to take the data embedded in the code, or we're going to take the code and embed it in the data. That works for most simple desktop GUIs. For simple desktop GUIs, you can either do 1, 2, or 3. That's all I'm saying, that almost all textbooks either do 1, do 2, or do 3. It's hard to say which one of these they do more. I've been looking and looking and looking, and I'm seeing about equal amounts of 1 and 2, and occasionally somebody does 3. Okay, so they do these they do these 3 a lot. They rarely do 4, but 4 is the hard part. Our homework assignment does 1. Keeps things real simple. For starting, keep it simple. So the data is going to be dumped into the object that holds the code. Okay? And like we said here, what that means is the data is all initialized by the constructor. Okay. Okay. So the data is all initialized by the constructor, and initially I set it up so the data is all buried in the constructor. I didn't make any of it shared, but the code's going to be down here. You're going to have to solve the problem that this code needs to get access to this data. And basically you do it by pulling some of the data from in here up here to instance variables. Okay, so you'll want some, or instance variables, or what people call fields. You'll want some people call them instance variables, some people call them fields. You'll want to create some fields. Once you've got fields up there, the constructor will fill them in, initialize them, and then all these methods down here have access to those fields because they are instance methods. All the event listener methods now are instance methods, so they have access to the instance variables. Okay, so you'll need to decide what state information goes up here. That's something I leave up to you to decide. What state information needs to be up here so that it's initialized by the constructor. Now, the constructor here is initializing the GUI. The constructor initializes the GUI. The GUI is not actually the state information. That's one last thing to mention about this. This is a real subtle idea, and I mention it in the homework assignment. There's one paragraph you should be real careful about. Let me see if I remember where it is. This right here. Probably should have made that even a separate paragraph because it's important. Remember a minute ago I said the state of the circle would be to remember where its center is, because that's about all you need to know if a mouse clicks in it. Notice that the center of the circle is not what the renderer keeps track of. What the renderer keeps track of is all the points around the edge of the circle. Like for the square, what does the renderer keep track of? That vertex, that vertex, that vertex, that vertex, and that line segment, that line segment, that line segment, that line segment. The renderer doesn't keep track of the center of the square, it keeps track of the corners of the square. Suppose you tried to use the corners of the square to figure out if you clicked inside the square. You could, but it'd be a lot easier to keep track of the center of the square. So notice that what you need to keep track of is different than what the renderer needs to keep track of. Okay, same with the circle. The renderer is keeping track of about 30 points around the perimeter of the circle and the line segments that join those points. Okay, so the renderer is keeping track of 64 points. Okay, I put 64 points around the perimeter of that circle. Okay, so the renderer is keeping track of those 64 points, and then there's 67 edges to connect them. The renderer doesn't know where the center is. The renderer doesn't care. It just needs to know those points going around there. The model that the renderer keeps track of is not the model you want to keep track of. You actually want two models for every model up here. This is the idea described in this paragraph here. You need a second model to represent each of these models. You need a model that's good for the GUI, not good for the renderer. And the model that the GUI needs is simpler than the model the renderer needs. The model the renderer needs for the circle is 64 points and 65 line segments. The model you need for the GUI is where's the center? And also the radius. You got to keep track of what the radius is. So you need to know center, radius. When I drag it, the radius doesn't change, but the center changes. Now, when I drag it, I have to update the GUIs. Okay, so when I drag this, I have to update both models. I have to tell the renderer that all the vertices have moved, and I have to tell my other model that the center is moved. Okay, so this is explained in this paragraph that you have to keep two parallel models going on. One model is built into the renderer already. That's the geometric model that keeps track. A square is 4 vertices and 4 line segments. The diamond is also 4 vertices and 4 line segments. The circle's 65 line segments and 64 vertices. But so that is the data the renderer needs to draw them. If you need to figure out, did the mouse click inside the circle or outside the circle, what you need to know is not what 64 points there are around the perimeter of the circle. You could use those points to figure out if you're inside or outside the circle. The code would be nightmarish. You could do it, but you wouldn't want to. What's a lot easier is to say, oh, I know where the center of the circle is. I know the radius of the circle. So when I click, I compute the distance to the center. If it's more than the radius, I'm outside the circle. If it's less than the radius, I'm inside the circle. Okay, so you need to keep, so over here, you're actually going to need up here some state information that's not the same thing as these models. You need some other models up here to keep track of centers and radius, center and dimension. Yeah, this is a circle of whatever center, radius 3. This is a square, side length 3, side length 2, side length 1. Okay, so that's part of what you're going to have to put up here. Is you're going to have to keep track of this, as it's described in this paragraph here. Yeah, you have to keep track of some other you have to keep other data in hand when you, for the GUI. Yeah, you need one set of data for the GUI and one set of data for the renderer. The renderer wants to know what it's supposed to draw. The GUI wants to know, am I inside or outside of shape? Okay, all right. So, okay, so that's the last issue with the homework assignment. You're solving this problem here, the state information versus the handler. Okay, this state information here is the state information here now really isn't the state information that the renderer needs. It's the state information that your handler needs, which is, we say, like, for its center and radius. But you need to update both. When you move them, when you move one of these guys, of course the renderer needs to be told that the circle is moved, but you also need to keep track of where that circle is so that you can go, the circle's over here, and I go over here, now I need to remember where the circle is. Somebody has to keep track of where the center of that circle is. Okay, all right, so that's outlining I think I've outlined everything you need to know for the homework assignment. It's real fast, it's a lot of stuff. You know, this is not a trivial homework assignment. Yeah, if you've never written this kind of code before, it's a really good example of an interesting little basic event-driven program that's doing reasonably useful information being communicated between the GUI, the renderer, and the events. Yeah, there's the render, which draws the circles. There's the GUI, which lets us control things, and then there's the events. Okay, so it's a kind of a nice merging of all these ideas. So read everything, and if you have questions, please ask, because you probably will. You have a lot to write, and you have to write it in lots of steps, and make sure you do it in the order that's done here. And then if you have if you hit a wall at a specific step, then you can ask about that step. Yeah. So if you can get through 3 steps and then you get a wall at the 4th step, then you can ask a real specific question about, I couldn't get this one thing done. Okay. All right. So so on Tuesday next week, we're going to start talking about the next render. Actually, so we haven't done this yet. We're going to do the clipping. So we're going to start talking about the clipping algorithm. Okay. So the next week will be about clipping. Okay. And then I still haven't rescheduled the midterm. I mentioned before the break that I would reschedule the midterm. I haven't picked a new date for it. So this is still showing the old date. So I'm going to pick a new date. Let's see, where are we now? Probably 2 weeks after that, That'll give us time to finish the clipping and then, so that'll give us time to finish clipping. So I think if anybody has an issue with that, let me know. But I think 2 weeks after what it was scheduled for here. Okay. All right. So if you have questions, send me emails or come to office hours or arrange a meeting. And does anybody have a question, real quick?
Go ahead.
Do you have a office hour today?
No, I have another class this afternoon. But you can send me an email or if you want to talk like in the evening. But I got another class after this one.
When are you available in the evening?
Most of the evening. I mean, I eat dinner. I got class, and then eat dinner like after 7.
Okay, I'll send you an email if we can schedule an appointment today at 7.
Okay. All right.
Thank you.
Anything else? Any other question?
I have one, but it's not specific to this class, so I'll try and catch you on office hours
Okay. Sure.
or
Okay.
send you an email.
Okay. All right. So then I'll stop the sharing. And okay, I'll go ahead and end the meeting. See you. Have another nice weekend. See you on Tuesday.
You too.